first thing here is the notation. This means that we are taking the derivative. This means that we are taking the antiderivative. So whenever you see this notation, this means take the antiderivative, then take the derivative. So there is a shortcut to the fundamental theorem, and I will show you that shortly. I'm not even going to wait a couple of days. I will show you. But I'm going to work it out the long way so that while you are watching me work it out the long way, I want to see if you can figure out the shortcut. So whenever you see this notation, you should think, okay, fundamental theorem. This is the derivative of the antiderivative. So I'm going to take the antiderivative first and then take the derivative.
Wait, why would it's not just the same thing?
It's not, you'll see. Okay. So I'm going to set this aside for just a second. And the antiderivative of t squared is 1/3 t cubed, evaluated from 1 to x.
You want to write this down?
Yes, Jacob.
Well, I don't know if
Write
we
the
were
notes down.
I don't know if we were doing the shortcut after or anything.
You will find that if you take good notes and study your notes, that it will help you.
Well,
I'll just say that. Okay, so now, in just a second, I'm going to take the derivative, but I'm going to plug in my bounds here. So that will give me 1/3 x cubed minus 1/3 1 raised to the 3rd power. Okay, so all I did here was anti-differentiate. I took the antiderivative of t squared, and then I plugged in the bounds. And so now I'm supposed to take the derivative of this that's inside the parentheses. Okay, so what is the derivative of 1/3 x cubed? X squared. And what's the derivative of negative 1/3 1 raised to the 3rd power?
1/3.
It's 0. Why is it 0? Because it is a constant, and the derivative of a constant is 0. So I'm done. That's it.
So same answer.
Let me do another. Okay. Same thing right here. I'm going to take the antiderivative of cosine of t, which is sine of t. And then that is evaluated from pi over 6 to x. So I'm going to take the derivative again in just a second, but first I'm going to plug in my bounds. So I have sine of x minus sine of pi over 6. And I'm going to take the derivative. Derivative of sine of x. It's cosine of x. Derivative of negative sine of pi over 6. 0, because it's a constant. And so what's the shortcut? I'm going to take the x and plug it in. And so if I have the derivative of the antiderivative, I take the x, plug it in, and I get f of x. It's pretty straightforward.
Why does this stupid thing get like the whole big brand on it? You know what I mean?
Why is this?
I'm not done. I'm not done yet.
Why is
I'm not
sine
done.
of pi 60?
Because there's no variable. It's a constant.
I mean,
The derivative of the,
so
it's a number. It's a number. And what's the derivative of a number?
0.
0. Okay, well, here's the next case scenario. What if the variable is on the bottom bound and not the top bound?
You flip it.
Well, that's a pretty good hypothesis. Let's check it out, shall we? All right. So I'm gonna have the derivative. And I take the antiderivative, which gives me 1/3 t cubed, evaluated from x to 4. And so, just a second, I'm going to take the derivative, but I'm going to plug in the bounds. So that's giving me 1/3 4 raised to the third power minus 1/3 x to the third. And now I'm going to take the derivative. Derivative of that is 0. Derivative of this is negative x squared. So you are correct. If this is the lower bound, then it's going to be negative f of x. Okay, well, I got one more. Notice that up until now, it's always been an x that we were plugging in.
Please mention.
What if it's x squared? How will that change it?
Well, let me
Put
plug
two
in.
in front of it.
Let's work it out and see. Okay, so here we go. Antiderivative of cosine of t is sine of t. So now I'm going to plug in x squared. And that gives me sine of x squared minus sine of pi over 6. Everybody okay?
So far, so good.
Now I'm going to take the derivative. Derivative of sine of x squared is cosine of
X squared.
x squared. Then I multiply it by the derivative of what's inside, which is 2x. And the derivative of that is 0 because it's a constant. So what's the shortcut?
Chain rule.
Okay, so you're saying I plug, if this is the derivative of the integral of g of x from a to g of x of f of t dt, I take the g of x and I plug it in,
Uh-huh. Times.
and then
G.
multiply times the derivative of the bound. Okay,
Where have you seen this?
you're not.
Yeah.
Well,
Oh, no,
what about, up until now, I've always had a constant for one of my bounds. So what if I have two variables? Then what do I do?
The multiplical rule. When you multiply them, first times the second one, and then the second one times the first one.
Make one negative.
Okay, so hold on. I plug this in. So this would be f
Oh, the chain
of
rule.
h of x times
Derivative of both of them.
times h prime of x, and then
Times
Minus-
minus. Oh, my.
Because first time's the, or
Look.
final minus initial.
Ah.
and then I plug in the g of x, so I get f of g of x
Okay.
times g prime of x. There we go. Okay, so let me do a little quick summary here. Anytime you see this notation, we're doing the derivative of the antiderivative. That's the fundamental theorem of calculus, part 1. If we have a variable, we're going to plug that variable into the integram for every variable, and then multiply the whole thing by the derivative of the bound. The constant is just going to be 0 because when we multiply by the derivative of that, it's 0. If our variable is on the bottom, it's going to be the negative value. If we have two variables, we're going to plug them in, take the derivative, plug them in, take the derivative and subtract the lower bound from the upper bound. Okay, so take a look at part A and tell me the answer quickly.
No, not. Oops, sorry.
Square root of 1 plus 6.
Is that it?
Yeah, that's all. That's all you need.
Am I done?
Yes, sir.
Yes.
Yes, sir.
I was
That's it.
about to say you.
Okay, what about the next one?
The same thing. Wait, no, it's not.
I plug in the x.
And X.
Yeah.
And the derivative of x is just 1,
Nope.
right? So that doesn't change it. Okay, the next one though, the derivative is not 1. So I plug in x cubed. I've got 1 over 1 plus
X cubed
x cubed, and then
times 3x squared, baby.
yes, let's multiply by everything.
Hold up.
I plugged in the x cubed for
No,
the
I know that
variable.
part, it's the next one.
It's the
Okay,
chain rule.
what's the derivative of
No,
x
no,
cubed?
like I'm
This
making
one?
D.
Okay. So I'm gonna plug in sine of x.
Just do the chain rule again, Famo.
Okay, so I plug in sine of x. And then I multiply
Oh,
by
sine-
the derivative of sine of x, which is,
oh, sine X, baby. Alright, I'm done.
Let me just do this on the test and then
Are we doing this whole paper before the test, or are we doing all the certain part?
there we go.
I think it's the best to compliment for the type. It would help greatly productivity in a classroom.
All right, turn the page. So look, here we are. This is what I want you to realize on this part, okay? This is the exact same thing that we have just done. It's just the notation looks a little bit different. So it says, what if we took the antiderivative of a function and then took its derivative? So they say that f is equal to the integral from 2 to 5x of t squared dt. That's the antiderivative. And then they say find f prime. So this is the exact same question. It's just not written with the same notation of the d dx. So let me work this out the long way, and I'll show you this the shortcut works. So I want f is going to be the antiderivative of t squared, which is 1/3 t cubed. And then I evaluate from 2 to 5x. So I plug in my bounds. So I've got 1/3 5x cubed minus 1/3 times 2 cubed. So this is f. Then I asked to find f prime. So I'm going to take the derivative of what's inside the parentheses here. So derivative of 1/3 5x raised to the third power. I'm going to use the chain rule. 3 comes out front. 3 times 1/3 is 1. The 5x comes down. I decrease my exponent by 1, which gives me 2. And then I multiply by the derivative of the 5x, which is 5. And the derivative of the second part there is 0. Notice, again, fundamental theorem, shortcut works. I take the 5x and I plug it in. I get 5x squared. I multiply by the derivative of 5x, which is 5. Okay, so this is the same thing. It's just different notation. Okay, so go ahead and work out this problem for me.
Should we do the shortcut?
Sure.
Aw. Oh, no, wait a minute.
Sure.
And check with your neighbor. Make sure you did it correctly.
I need an eraser.
And check your answer with mine.
Yeah.
Okay, so here it is in all of its formal glory. Fundamental theorem of calculus, part 1. If little f is continuous on the interval from a to b, and then big F is equal to the antiderivative. And we have from a to g of x of f of t dt. So we take the g of x and we plug it in and we multiply by the derivative, assuming that a is constant. So we were just subtracting 0 there. And then if we have two variables in our bounds, we plug those in, multiply by the derivative of each one, and subtract the two. So let's look at a couple of examples, and then we'll be finished for today. So whenever you see this notation, it means fundamental theorem of calculus. Okay, it says find f prime of x. And they defined f of x as equal to the integral from 2 to x of 3t squared minus 1 dt. So I'm going to use the fundamental theorem. It's the shortcut. I take the x and I plug it in. And I have 3x squared minus 1. That's it. I'm done. This one. Okay, it's on the bottom, therefore I need a negative. I plug in the x. And oh, look, Newhouse has made a careless mistake, hoping that fourth period would notice. What is it?
Minus 1.
I need parentheses. Why do I need parentheses?
This is not actually. It's two signs.
Because it's the negative value of everything that is in the integrand there. So you got to include the parentheses. Okay. Well, next example, same thing. The notation's a little different. So I'm taking the derivative of the antiderivative, but I'm still going to use the shortcut. So I plug in x cubed. And I multiply by the derivative of the bound, which is 3x squared. And I've got a variable for the bottom bound also, so I'm going to subtract and then plug that in. And so I get sine of x cubed times 3x squared minus sine of x squared times 2x. All right. And so here, same thing. I see this. It means fundamental theorem. I'm going to take the x squared and plug it in. When you raise a power to a power, you do multiply. And I need to multiply all of this, though, by the derivative of the bound. So I'm going to multiply this by 2x. And so I could write this as 2x to the 6 minus 7 times 2x. And I'm going to leave it like that. Okay, so any questions over anything that we've done so far?
No, sir.
Okay, we are going to do one more example here. it says if h of x is equal to the integral from 2 to x of t squared minus 6t dt. Okay, when you see this, again, this notation means FTC. Whenever I see this h of x is equal to this integral from 2 to x, and then there's a different variable in the integrand, I know that they're going to ask me about h prime of x somehow. Okay, but they don't do it directly here. They say find the equation of the tangent line of h of x at x is equal to 2. So I need two things to write the equation of the line. I need the slope and I need a point. So let's get the slope. I need h prime of x. And this is where I use the fundamental theorem. H prime of x, okay, I'm going to anti-differentiate and then take the derivative so I can use my shortcut. I'm just going to take x and plug it in for each of the variables. So that will give me x squared minus 6x. Then I'll multiply, technically you multiply by the derivative of x, but it's 1. So I just have my derivative is equal to x squared minus 6x. Now what? Well, I want to evaluate, I need the slope at x is equal to 2. So I need h prime of 2. So I plug it in, that gives me 4 minus 12. So I know that my slope at x is equal to 2 is negative 8. And now I need a point. So how do I get a point?
Your formulas.
Well, I know what h is. Excuse me, h. I know what x is. I know that x is 2. So I need y. In other words, I need h of 2. Correct? Do you have an equation for h of x?
Yeah, it's up there.
It is up there. So why don't we substitute 2 in for x in that equation? And that's going to give me the integral from 2 to 2 of t squared minus 6t dt. And oh, look, I know that. It's what? Why is this equal to 0?
That's one of your rules.
Right, but explain it to me because I'm a little slow today. I don't get it.
It's the same point, there's no like change in anything. If there's just a straight line, there's no change.
So what you're saying is if I'm integrating from 2 to 2, which is a line, and I'm finding the area under the curve,
There's no change.
that a straight vertical line has no area. Therefore, this has to be 0. Okay, I'm with you. So now I've got my point. I know that x is 2 and y is 0. I know that my slope is negative 8, and I can write the equation of the line. Y equals mx plus b. So that's going to give me, so b is equal to positive 16. So my equation of the line is negative 8x plus 16.
Did you put it in slope?
Yeah, that's fine. That's fine.
So if that wasn't 0, then you would have to solve.
Yes.
Yeah.
All right. Well, finally here it says for what values of x is h increasing? So I'm going to say h is increasing when
Then, h prime of x.
so you're saying whenever the derivative, which is the slope, is positive, then the function is increasing. Okay. So h is increasing when h prime is positive. So how do I find when H prime is positive? How do I find critical points?
Do the derivative again.
Hold on, so H prime of X is equal to X squared minus 6X. And so what do I do?
Derivative again. Am I wrong?
Yes, I do.
How do I find the zeros? You're right.
I thought you.
I said this equal to 0?
Oh, then you take out an X.
Let me write that on a
You
different
good.
line there. Hold on.
So it's
So then we got X squared minus 6X equals 0. And I need to find the critical point. So I don't know about y'all, but sometimes it's not the calculus, it's the algebra
Yeah.
or the adding and subtracting and the multiplying and the dividing, right? I mean, it's not that I can do all this great calculus, but then my algebra betrays me, right? So how do I factor this?
take out an X.
Take out a 6 or an
Sorry,
X?
take
Take out an X.
Six now.
So that's gonna give me X minus 6. So then I've got X equals
0 and 6.
0 and 6. So how do I find when it's positive? A sign chart?
Sign chart.
Oh
But wait, what do I plug into?
I don't know. The original. I knew that.
Is it H prime of X or is it the original?
It's the OG.
The prime,
Original.
prime, prime.
my
No,
God.
Right?
it's
Prime.
Original.
Original is the prime.
Hold on. Let me think about this for a second because I can get myself out of this mathematical conundrum here. This says H is increasing when H prime is positive. So if I'm doing a sign chart and I want to know where the slope is positive, I'm going to plug values into the derivative. So if I plug in 1, for example, here, all I care about is the sign. I've got 1 times -5, which is negative. And then if I plug in -1, I've got -1 times -7, which
Positive.
is positive. And then if I plug in like 7, I've got 7 times 1, which is positive. So I can say H prime is positive on the interval from -infinity to 0 and 6 to infinity.
All right. Let's get those tests.